All right, guys. Now let's talk about ML engineers versus AI engineer, and this is the questions which I have been getting, lately, and this is the one of the most frequently asked questions which I've been getting on my, LinkedIn channel, and people are asking me to, give me explanation and to make videos around that, so that they will be, more structured towards their preparation, like towards how to approach that, this particular track. So first of all, for this confusion, I like to tell you one thing very clear here, because recently I have seen many JDs around this, into this AI track and in the ML track. What companies are also doing, they are actually building this and mixing this aspects, right, of ML engineers and AI engineers, and they are kind of cooking a story wherein they expect from an engineer, best of both the tracks, and that is where candidates are getting a bit confused. So that I thought, how to bridge the gap, and first of all, how to distinguish between these two tracks, and then we will talk about how to bridge the gap, right? So this is the core aspect here, which you can see at the in between, right? And on the left quadrant we have this ML engineer, and on the right side we have this AI engineer. So we need to differentiate between ML engineer and AI engineer on these core aspects, and that is where generally, like any industry, tends to lean about that, right? So let's get started and understand that. So what is the core focus area for any of this ML engineer? So let's first finish this left side stack itself, and then we'll come to that on the right part. So from that ML engineer perspective, the core focus area is going to be that training the models, right, which is going to be that. Then my primary goal is going to be obviously to improve the accuracy. So I would be looking into that angle, improving that accuracy. And then what I will be building. So in that particular case, I will be building that ML models, right? And looks like this font is a bit different. All right, so now this is looking fine. So now let's come here, right, and let's try to fill this blank, and let's get started with that. And what this input is going to be here. So here that input is going to be a structured data, and likewise I'm going to have this output as in prediction. So this is more like a traditional way of doing that predictions using ML itself, and that's what we are trying to get as an output here, right? And then the pipeline piece. So what is the pipeline going to come here, right? So here we will be building this training pipeline, and that's where your MLOps, which you might be hearing, right? So that gets handy here, right? And that is where, like, you will be building this complete MLOps pipelines, and you will be seeing that how these models are getting connected, and then how feature engineering is happening, and every piece is connected over there. Then if you have to see that whether is there any problem with the model, and if it needs retraining of that, so how do you identify that, how do you troubleshoot that? And these are the accuracy factors which you will be checking there, and then you will be accordingly training the model and putting behind the pipeline, and that is where training pipeline comes into the picture. Then key technologies which gets involved here over is like something like tensor flow, and I would say PyTorch as well. And let's expand a bit more here just to make sure that it apply that the same adjacent side. And then the success metric here, right? So these are the recall factors like precision recalls and F1 score, right? So I would say that, let's say recall, precision factor, and then F1 score, right? So these are the success metrics which you will be checking any of this model's performance, whether how's the F1 score, how's the recall value, and is that percentages going between 89 or 92, 95. So which model you have applied, which algorithm you have applied. Let's say you have applied any scikit-learn wherein random forest or logistic regressions comes into picture, or XGBoost you have done, or for different kinds of data set, it's going to be different algorithms which gets applied. So that is something which you will be, as an ML engineer, you need to think of that, and that is where you will be building this model. And what is this scope of this one, right? So the scope of this, when you think like this is going to be completely model centric, right? So you are actually building a system which can gives the prediction, and that has to be robust enough, right? So let's say you are building any recommendation engine, or you are building any kind of, claims prediction, or, healthcare prediction. So in that particular case, you will be working with the data set, right? And that is where, a structured data set, and that is how this is going to come into play, like which algorithm you should be deploying to make maximum out of that. And you will also be doing that, feature engineering on top of those columns, like whether it's making sense or not, and then you will be, accordingly applying all that algorithms on top of that one. So this is where your ML piece comes into picture. And then when it comes to the deployment piece, so it's like model serving, right? So, and then it comes with, because this deployment gets hand in hand with the infrastructure, where your MLOps pipeline comes handy. And this is where this is pretty interesting, and this is the buzzword which is around the industry, like everybody is talking about the MLOps. But the fact of the matter is not only about connecting the dots. You need to know the basics, fundamentals, like to getting started with the maths, like probability, and trying to understand like how these things works behind the scenes, like and then trying to work on that scenarios, like in which scenario which algorithm fits well. Once you understood that concept, like how this is fitting, how the algorithms are working, where these algorithms needs to be applied, then the template is pretty simple. For any of the use case, you will be following the same standard template, and that will be the same thing across. And then we have this thinking style, right? So from the thinking style is like it's more working on this on the stats itself, right? So it is going to be statistical thinking, right? So that's what I will put here. And statistical thinking. And finally, the end goal from ML perspective, like any ML engineer, is like machine learning. That means machines is going to learn that one, and that is what you are building the model here. So here machines learn, right? And now let's see the right quadrant here. And the right quadrant is also going to be from the fact of the matter is like right from the beginning itself, like from the core focus and how this is going to be. So we are going to build this intelligent system. So I would just start with that, like building intelligent systems. And let me just take this guy a bit closer here. Yeah. Now, what's next? What's your primary goal here? And my primary goal is going to be deliver business outcomes. So deliver business outcomes here. And what this guy is like AI engineer is going to build here, right? So this guy is build AI applications and agents, to be straight, AI applications and let's say agents, right? And obviously how it's going to work with, right? So works with, it's going to be you will be working with the context, like and that knowledge, like if you have heard of this RAG application, right? So there you will be working with the documents, the chunking style, how you are chunking, how you are embedding. So everything will come into that picture, and that is where you are building the knowledge base here. And that's where context comes pretty handy. And don't worry about that, we will be talking about all these things in details, right? So not to get overwhelmed. So if you are coming for the first time here, I'm just giving you an scenario wise, like the aspect wise, the distinction between all these two, like ML engineer and AI engineer. So context and knowledge, and then what's next? So it is the input. It's going to be a structured or unstructured data. So it can work on both, right? Structured, unstructured, or you can say semi-structured as well, because that way you just need to design the system in that way that it can adapt to that. But this is flexible enough to work with that one. Now this is your input, and this is looks like it's getting little. Let me just, now what is going to be output here, right? So if I come here, right, so for output for this one is going to be, let's say, actions and decisions, right? And that is what you will be seeing with that, agents and the tools which you will be here using that one. And then we are having this pipeline, right? So from the pipeline perspective, it is going to be like agent working, agent workflow pipeline. And this becomes pretty handy there, right, once you are building this particular system. And this is what agent workflow pipeline. And the key technologies which you are going to use here is, you might have heard of this LLMs, RAGs, agents, vector DBs, and all these, like, so this is going to be your day in and day out playing with these tools, RAGs, and let's say agents. So these are the factors which you will be using here more often, right? And then the data flow, how it's going to be the data flow, right? And if you think from that data flow perspective here, right, so this is going to be your data knowledge action, and looks like I have missed that one into that. So it's going to be data knowledge and action. And for this guy, let's also mention this data flow. And this data flow, let me just take it here. Yeah. So what is going to be the data flow for this one? So here you will be having data, which is going to your model. And likewise, you will be doing prediction. And let's expand a bit. Yeah, now makes sense. And now this is little bit alignment, making sense. And so now let's come to that AI engineer quadrant, and here let's see that what is the next bit here, like, and this is the success metric here. And the success metric here is going to be user impact and the business value from AI engineer perspective. So it's going to be like user impact and business value, like what business value because this is directly related, like what kind of business value you are putting to the table, you are bringing to the table, right? So this is going to be quickly calculate, I mean it can be quickly measured there, right? And that is where people compare these things, two factors here. Now the scope of this one, right? So the scope wise, if you see here, like what's happening, so scope wise, this is going to be 100% system metric, right? And here it was model centric. I would say that this is going to be system centric, like what kind of business application you are building, and that is what my scope is going to be. And again, then the deployment is going to be your end-to-end AI platform. So end-to-end AI platform. Now comes to that infrastructure perspective, right? So here it's not like MLOps is the only term here which we generally use in ML engineering perspective, but in this case this is pretty broad term. I would use this AI systems engineering. So I would be saying that this is going to be AI systems engineering. And then from the thinking style perspective, so here you will be doing the systems thinking, and that's where your systems thinking means like your software engineering. Let's say you have been building applications from .NET, Java or whatnot, from that enterprise perspective, which you have already done from system design and other pieces, right? And that flow, like, and how to connect the dots in order to principally solve any problem statement, right? So that is what the system thinking gets applied directly over here with this business insights which you will be building, and with these tools which is on the right quadrant, right? So this is where people can connect the dots quite quickly then, rather than ML engineer perspective, because from ML engineer perspective you will be working on the ground, rather building the models, working with the data, working with that features, thinking why this model is not working, why is that, like is there any discrepancy there in that data set, or is there any discrepancy in the algorithm which has been chosen, or something to do with the MLOps pipeline. So that ways, right? So that was completely model focused, and here this is completely system centric overall picture that is going to come here. So I would say here this is going to be a system thinking, and the end goal here is going to be business use case, or business use AI. So that is what the end goal, because here you will be building the chatbots, here you will be building that knowledge base for that RAG system, you will be deploying these agents, whether it's going to be your LLM agents, or I would say that's rule based agents. So based on that, this is going to pick up that which flow, which tool it is going to call. So this entire agentic AI agents, MCP, everything will fall in place and connect to the dot here. But to get started with, and this is where this ML engineer comes into the picture, right? So these are two completely different track. So I hope this is clear. Now, one more thing which I wanted to bring to that focus here, right? So I have already built this system, right? And that is where I wanted to quickly share here. And let me just show that piece here. And this is what you can see here, right? So this is what I am doing basically, right? So let me just expand a bit, and I've also put this as an infographic, like just quickly compare this between this ML engineer and AI engineer, and this is the same thing like which I have just explained. I hope this is making sense here. And in order to get inside, right, so in case if you guys are feeling a little overwhelmed, so I have already published this my free course, which is there, getting started with document intelligence. This is also there on YouTube. You can see that whether it's making sense to get started with that, and to understand like how these things works together when it's and if you guys like to get into the skin of the character and get the feel of that, how that transition from a traditional software developer to AI engineer or to ML engineer, how it will happen. So for that particular thing, I have built this complete pipeline and AI engineering roadmap, right? So you can definitely check this out in case if you guys are interested in delving deep and trying to understand that, like how these systems are working and how the dots are getting connected. So this is this entire roadmap, like foundation layer, like document processing and AI data, wherein you will understand like how this PDF ingestion happens, how text extraction happens from that, and then how do you organize these documents, and basically how you do the data preparation. This is perfect for beginners, which is means like it doesn't matter whether you guys are coming from .NET background or Java background or from any other background. Even if you are starting afresh, this is going to be right launching pad for you guys. Then the second layer which comes here is basically we are switching the gear here, and we are building this AI application layer, which is where RAG agents and intelligence systems comes into the picture, and that is where you learn this with that AI document intelligence and RAG agents, right? So, and this is where what happens here is that PDF processing and extractions starts here, and then you will be doing this, building this RAG pipeline, where in this chunking, vector database and complete RAG pipeline comes into the picture. Then you will be building AI agents from scratch. That is what I spoke about, this rule based agents and this LLM agents. And then again you will be seeing that building a tool like where it will think based on that which tool it needs to be invoking, whether it should be going to land on the LLM or it can use the rule based one, because there are caching layer which you will also be building to for that queries which has already been answered by the LLM. So that way you will be saving the token and trying to understand that how to build an enterprise level system which is very much guarded with the guardrails, because you won't be wasting tokens from there. And also from the perspective like how the industry insight and business value is getting delivered. The outcome of this one is going to be, a structured data extraction, because you will be starting from PDFs, and then you will be, building as an outcome as a CSV, which is going to be the input for this MLOps pipeline. And that is the outcome of this is going to be faded over here. So you see the complete roadmap. You started with the foundation layer from nowhere, and then you are ending into that MLOps pipeline where you are doing all the complete set which any of this MLOps or rather ML engineer is doing. So this is the second track, is something which AI engineer is doing. Third track, which is something which MLOps engineer is doing. First track, where everyone is getting fit in, where who wants to learn something from the beginning and try to transition from the current state to the future state. So this is what I talk about, the bridge, and this is how this transition is happening. And that's where many of these folks, my students, have reached out to me and asked me for one-to-one mentorship, like how should I do that. So in case if you guys have stuck in your career, right, and you feel difficulty in switching in any of these lines, so you can definitely reach out to me. You can just ping me on my LinkedIn. You can just follow me on LinkedIn, and you can ping me there and ask for a mentoring session. So I can definitely book for a session for you with the complete roadmap, because this is the thing which I have implemented myself, right? Because overall 18 years of experience, and I'm principal architect and handling this Niva Bupa, right? So from that perspective, if you think that like how the transition happens and how this I'm building this intelligent systems over there, and the cloud transformation by building this and connecting these dots, like, so this is pretty insane. And I'm 100% sure you can also apply this template using your existing software engineering skills to apply this, how to build these intelligent systems. I hope this has made sense to you guys. In case if you like to get in touch with me, I already have the link pasted there in that in the description. So do reach out to me. Having said that, let's get started.